Welcome to another installment of Odd Problems with Mr. Lorenz. Today we want to finish going through that section 7.6 worksheet, those odd problems numbers 5 and 7. Let's get right up here. So we are looking at f of x equals negative 2 log base 4 of x plus 5 minus 3. And the easy stuff we should get cleared out here right away. This negative 2 tells me it's going to finish down low. So let's go ahead and say that it's going to start up high. Okay, start high. Of course, it'll finish down low. With that in mind, let's talk about the vertical asymptote. Reminder, our vertical asymptote and our domain are really going to come out of what's going into the log portion of the function. So the x plus 5 equals 0, or x is negative 5, is going to tell us where my vertical asymptote is. My domain is going to say that all my x plus 5 values have to be bigger than 0, or all my x values have to be bigger than negative 5. Now, if you look closely here, you'll see I already set my graph up so that my axes and my grid lines are all counting by 2's. So that right there is the line x equals negative 5. Okay, x equals negative 5 right there. Is that vertical line. The turning point. Reminder, the turning point can't take the log of 0. The turning point, we said in our last video, was when x plus 5 was equal to 1. Remember, the output of an exponent is what the input to a log function is. So if we think about our turning point from our logarithms, when I used 0 as an exponent, I got out a 1. Well, now we're going to use our logarithmic functions, so we're going to put a 1 into the log function to get a 0 out. All right, so we're going to go f of, well, let's figure out what x is. I'm sorry. X would be then negative 4. So f of negative 4 is going to be negative 2 log base 4 of negative 4 plus 5 minus 3. And once again, we said this before, but this should be 0. If we did this right. So let's go negative 2 log base 4 of 1 minus 3. Log base 4 of 1. 4 to what power gives me a 1? Well, that's the 0 power, so negative 2 times 0. And once again, not a big surprise. Anything times 0 is 0, so we'll have 0 minus 3, or just negative 3 for this portion right here. And that gives us the point negative 4, negative 3. And that's the first point that I'm looking at on my graph, negative 4, negative 3, which is going to be right about there. Okay. Now, the next tricky part that we discussed the other day, or in the previous video, I should say, was the idea that we're going back and forth between exponentials and logarithmics. And really, it helps us to kind of understand this example. We want to take these as being our inputs into the logs, not in for our x, but into the logs. So we already did this one here. Actually, let me go back and redo that with this, because that would be color-coded to our turning point. And then to go find 2 additional points, let's think of it this way. Let's say x plus 5 has to equal 4. And let's go ahead and use x plus 5 would have to equal 16. Those are the 2 remaining ones that we have. So let's put in an x value of 11, and let's put in an x value of negative 1. Find out what our y values are. So I have f of negative 1 is equal to negative 2 log base 4 of negative 1 plus 5 minus 3. If I start simplifying that down, I get negative 2 log base 4 of 4 minus 3. Remember what's being asked here? 4 to what power gives me a 4? That's what this is asking. 4 to what power gives me a 4? So with that in mind, 4 to what power gives me a 4? It's a 1. So I have negative 2 times 1 minus 3, or negative 2 minus 3, also known as negative 5. So we have the point negative 1, negative 5 as part of our graph. And that guy's going to actually be right in the middle of a mess right there. Right in the middle of a square. So we'll do f of 11 then. And f of 11 is going to be negative 2 log base 4 of 11 plus 5 minus a 3, or negative 2 log base 4 of 16 minus 3. Once again, I ask you, 4 to what power is 16? And hopefully you said that would be the second power. So now we have a negative 2 times a 2 minus a 3, negative 4 minus a 3, which is a negative 7. The tendency that I see with people who make mistakes going through this is they get so excited when they figure out that this log base 4 of 16 is 2, that they forget they got to multiply it by the negative 2 that's right here before they subtract the 3 or something along those lines. All right? Don't forget what you're doing, okay? Stay calm and finish the race, all right? So we have this point right here, which is 11, negative 7. We had this point right here, which was negative 1, negative 5. And we had the negative 4, 3 before. Let's go ahead and put this graph together then. It's going to start up high, and it's going to turn right through these points and head off in this direction right here. All right, and there's that problem. On to number 7. Number 7, similar kind of thing. We have a positive 1 out in front, so it's going to start, or it's going to finish up high. It's going to start down low. Okay. Start down low and finish up high. With that in mind, the vertical asymptote, once again, looking at just the x minus 5, the x minus 5 is equal to 0, or the x minus 5 has to be greater than 0 for our domain. We find out that x equals 5 is our vertical asymptote. I'll put that right over here on my graph. Once again, you can see my graph already has some, it's counting by 2's if you can't see that. I don't know, that might be a little bit small. I shouldn't say equals, I should say equals. Equals 5, x equals 5 is our vertical asymptote, and everything should be bigger than that. Okay. So if everything's bigger than that, we'll keep going from there. Hang on. Sorry, just had to take care of something there. Turning point, once again, we're going to set that x minus 5 equal to 1. So our x is 6 is going to give us our turning point. Our f of 6 is going to give us a log base 3 of 6 minus 5 minus 1. We're not surprised by the fact that we're going to have a log base 3 of 1 minus 1. Log base 3 of 1 is always going to be 0 minus 1, and we end up with a negative 1. So we end up with a 6, negative 1 for our turning point. Okay. The reason I've been starting as opposed to where it finishes is when you go to graph, you need to know where to start along the asymptote. And that's I think, why when I wrote this, I said, where does it start? Because as you come across this, you're always going to start along the asymptote and then curve away from it. So that's why I think I started with that. And you can see that kind of happening. All right, let's go find our other points here real quick. Once again, we're in a base 3. So 3 to the 0 is 1. We already found that guy. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. So we're looking for things that would make this work. This 3 right here is why I would say x minus 5 equals 3 is something I'm interested in. In other words, x being 8 is an input I might want to discuss or might want to look at. Log base 3 of x, I'm sorry, I shouldn't say x. I should say 8 minus 5 minus 1, or a log base 3 of 3. Log base 3 of 3 is 1, so we have 1 minus 1, which is 0. All right, and that's where we get the point 8, 0 from. And let's get one more point here. So let's say, well, let's look at 3 squared equals 9. So I want that x minus 5 to equal 9, which means my x value would have to be 14 for that to occur. So let's go ahead and plug 14 into our function, and we'd get log base 3 of 14, 14 minus 5, log base 3 of 9. 3 to what power gives me 9? And that would be the second power. And that's how we end up with a 1. So we end up with a 14, 1 as a point on our graph. So there's 14, 1. I missed 8, 0. Let's go back and put 8, 0 on our graph. Okay. And then let's go ahead and graph this. It's going to start down low, it's going to come on up, and it's going to turn rather quickly here and go off in that direction. Part of the reason it's turning quickly is because of my scale. Part of the reason is because the bigger the base of the log, the quicker that's going to kind of occur over time. I hope these videos have been helpful to you to get a little bit of an example as to what you're looking at. And keep plugging away and doing your best, all right? Look forward to seeing you guys all again.